All right, well, this is our last screencast of new work for the term. The next one doesn't actually have a screencast because it doesn't require one. So we're going to talk about a different type of graph now, and that type of graph is called parabolas. So all the stuff we've done so far was nearly all linear graphs or straight lines, and we also looked at some curves when we were talking about indirect or inverse proportion. But there's lots of other different types of graphs, some of which you'll again look at next lesson for other nonlinear graphs. But the one we're going to look at this time is called a parabola. And a parabola is formed when you graph a quadratic equation, which we learned to do stuff with last term, quadratic equation. So just a reminder what a quadratic equation is. They're the types of equations, so it's just still an algebraic equation, but it has squared terms in it. The highest term in it is a squared term. And it's the general form of that equation is y equals ax squared plus bx plus c, and a, b, and c are just constants or numbers. So there's some things we need to learn about a parabola and some certain features that we need to be able to talk about. So let's have a look at them now. So a parabola is symmetrical. It's a curved graph. It's symmetrical about a line that's called the axis of symmetry. So you can see it's actually in the center of the curve. Axis of symmetry. It has one turning point, so that's where the graph changes direction, and that can either be a maximum, which is at the top, or a minimum, which is at the bottom. But there's only ever one turning point. It might also be called a vertex, but we tend to call them turning points, and it's either going to be at the top or the bottom. So parabolas can either face upwards or downwards, and they're still perfectly normal parabolas. Depends on the equation that relates to them. So there's an example here of a parabola. Now this is for the equation y equals x squared minus 4x plus 3. And let's have a look at all the key features on this graph. So the axis of symmetry is straight through the center, and you can see it actually cuts through the x-axis at 2. So because there's no y-intercept, you'll remember back to that lesson that the equation of the axis of symmetry must be x equal 2. It's a vertical graph, vertical line, and never cuts the y-axis, x equals 2. We can read off our graph the turning point as well. The turning point is always on the axis of symmetry. So wherever that is, one of your coordinates should be given to you. So in this case, our x coordinate is 2, and if we read off the graph, you can actually see that our y coordinate here is -1. So that makes our turning point 2 and -1. We can also read our x and y intercepts off the graph. Now, you could have 2 x-intercepts, 2 y-intercepts. It depends where the parabola is drawn on the axes, on the Cartesian plane. So each one could be different, but a lot of times you've got 2 of one and 1 of the other, which is what we have in this case. So you can see we have 2 x-intercepts. It intercepts the x-axis at 1 and at 3. So that makes those points 1 and 0 and 3 and 0, and our y-intercept, it only intercepts the y-axis once at 0 and 3, because the other side of the parabola is off in the positive quadrant of the Cartesian plane. So let us have a go at finding the features of a graph that we're given. So the things we're interested in, and even if you're not told, you need to understand that this is what you're looking for, is the equation of the axis of symmetry, which you should be able to find because we've done that so many times now. It's just usually an x graph or a y graph, so it only cuts one of the axes, usually x. The type of turning point, is it a maximum or a minimum, the coordinates of that turning point, and the x and y intercepts. So let's work with this graph and see what we've got. So the first thing I'm going to do is draw the axis of symmetry straight down the middle of the graph. So you can see the axis of symmetry goes through the parabola at the turning point. So in this case, our axis of symmetry cuts our x-axis at 2, and it never cuts our y-axis, so our equation for that line is x equals 2. Our turning point, our turning point is a minimum. That is the lowest point in the parabola, so that's how you can tell if it's a minimum or a maximum. It's either going to be the lowest point or the highest point. The coordinates of the turning point, and you can quite easily abbreviate that to TP, that's fine, are at 2 and -1. You can read that off your graph. Your x-intercepts, again, read that off your graph, are at 1 and 0 and 3 and 0, and your y-intercepts, again, read off your graph, are at 0 and 3. Now, you may have noticed that this one we just looked at is actually the same graph as the one we just looked at in our example, but you can see where all of the information's come from, I hope. So x and all of these points are the ones we're interested in. I've marked them on there and drawn the axis of symmetry. Okay, so let's try plotting one. It's easiest to plot it by completing a table of values because that's going to give you a few points that you'll be able to draw the curve through. So once plotted, we need to state the features. So let's try this now. Okay, so we've got an equation there, y equals x squared minus 1. We can tell it's going to give us a parabola by looking at the equation. We've got a squared term there. Now, we've got no x to the power of 1 term, but that doesn't matter. It's still going to give us a parabola for this equation because of that squared term. So that's how we can tell. So just a reminder, how to find that. We're going to substitute the x values into our equation to find the y values they give us. So I'll just do the first one here. So if x is -2, substitute that in. Now remember, it's all of -2 squared. So -2 times -2 actually becomes a positive. So our first value is 3. So keep going and do that with all of them. You'll notice it tends to form a pattern for a parabola. So the x values form a pattern, the y values form a different pattern, and that is totally normal. So let us plot it, and then let us write down the features like we did before. So I'm just going to draw straight down the center. You're of course going, oh, see, terrible, terrible lines. You guys, of course, are going to use rulers. Now, need to go as high up as 3 on my positive y-axis and as low as -1, and I need to go as high as 2 and as low as -2 on my x-axis. So let's plot that now. So each one of those points you need to plot. So -2 and +3 will be up here. -1 and 0 will be on the x-axis. 0 and -1 will be on the y-axis. 1 and 0 again is on the x-axis, and 2 and 3 is up here. So you can see we've actually got 5 points and they're forming a pattern, so we can actually draw a beautiful smooth curve through them. So do your best at doing this. It should be a nice smooth, not pointed, although mine's a little bit pointed and not very smooth, curve through those points. I might have one more go at that. Don't know if it'll make it any better, but anyway, let's see how we go. Don't think it really made it any better. In fact, I missed the point there. So final thing you should do is make sure you write the equation on the graph. No different as before. All right, now let's look at the features. So the axis of symmetry, not actually on there, but I'm just going to change color for a minute because it's going to be hard to see in this case, because our axis of symmetry is actually goes straight through the center of our graph, and that is our y-axis. Let's go back to black. So in this case, our axis of symmetry equals our y-axis, which is perfectly fine. Our turning point is a minimum, and we know that because it's the lowest point in our graph. Our coordinates of our turning point are at 0 and -1. And you could have actually probably told that just by looking at the table, because you can see here that these are the lowest values that we've got. They're our lowest y values, and that's what we're interested in. That's what gives us our turning point. Our x-intercepts are -1 here and 1. And you can also tell that because they are the values where y equals 0 in our table, and our y-intercept is the same situation. It's the same as our turning point, but in this case it's also the same as where x equals to 0, which means our x-intercepts are also -1. So that is how you draw a parabola, and that is how you find the features of it, and you need to be able to recognize it from the equation. So you need to do some questions from the textbook. I've also set some harder ones for those of you who are finding this too easy. Have a go at question 10 and 11. There's no screencast after this. So your job, there's one more lesson, but there's no related screencast. Your job for homework is just to finish anything you haven't done so far. And our last lesson is other nonlinear graphs, which we will look at in class. All right, see you then.